we're just going to go back over a little bit of the wave. I gave some early input on CMS Wave on the first day, but there's some other things that we might want to discuss a little bit. And so, CMS Wave is a steady state 2D phase averaged model. It is not phase resolving. Those are generally a lot more computationally intensive, and they're typically used on HPCs or larger systems than we have here. So we're solving the 2D averaged, wave averaged equations. So we have wave diffraction, reflection, a lot of different capabilities. We can have wind input that affects the waves, transmission on different structures, and I'll show a few examples of this as we go through the slides here. We calculate wave run-up and overtopping, and you can have variable grids just like we did with the flow and we were talking about. We can do the same thing with nested wave grids. And then we have some early infragravity type nonlinear terms that we can turn on to get a little bit better reaction in certain situations, but it needs more testing and more work on that. And then we also have a fast mode so that users can get a faster answer earlier on, and then they can turn it back off when they go into production type mode. And then that way they can kind of see, an early answer that's not quite as accurate, but it gives them the general effect of what's going on with the waves. And I'll show a little bit of that. So these are just, I showed this the other day for some of the different capabilities and the way that they're represented with theory formulas or otherwise. So the CMS Wave model control within SMS has, it's changed from even 13.2, and earlier it's being done with this new dynamic interface. So we've changed the model control a little bit. We have a parameters tab, boundary control, output control, and options. We'll get into a lot of detail on this tomorrow and what each one of these is, so I'm not going to go into it here. But we're able to specify all kinds of different attributes and set up the model to everything that we need to be running. So we can gather wave forcing through spectrum from different buoys, whether it be NDBC or CDIP. WIS stations provide a spectrum. We have ADCP instruments that are put out there. And then we can also generate it within SMS or some other script to generate a spectra based on wave criteria, and then use that to force the wave model. So inside SMS, once the spectral grid has been created, you can look at it. This is what you typically see, although it's normally shown in a full plane circle here. But sometimes you may just be forcing with a half plane, which is this 180 degrees or so. And then you can rotate this and see what the spectra looks like. You see this is very symmetric, so we can tell that this was a generated spectra from characteristics. Otherwise, it would have multiple peaks and have some variability throughout that spectra. And then these two plots you can turn on, and it just basically shows a slice through the middle in one direction or the other. So there's jetties and diffraction that we have capabilities for. So we have a jetty here, and then as the waves are coming in, there's less energy behind it because it can't make it over the jetty, but you do see some reflection and diffraction as it gets around the jetty and starts backing in this way. We have run a lot of different validation tests in testing this, and are pretty happy with the results there. We have several different wave breaking formulas. This is just one slide showing some validation work that we did, choosing different formulas and the results that we got for what the wave energy looked like, the wave heights. So we have Batches and Jansen, Goda, there's Meech, and I forget what the C and K was. But there are different options in the interface that you can choose to select which one matches certain areas that you might get better results with one than the other. With wind wave generation, we are able to change the effects of what's going on. Even if you're specifying a spectra on one side, if you have winds turned on, that spectra, that energy is affected by what's going on with the winds and the ways that those winds generate. And so this is just some early validation work on getting those compared with the shore protection manual. So this is one case I kind of showed the other day where we're running a Hurricane Rita over a grid here at Galveston or Matagorda Bay. And as the hurricane comes in, you can see that the winds and the waves are changing directions. And that's just how we're able to implement those wind-based changes to what's going on with the forcing. Right now, CMS Wave can only handle Cartesian grids, so that allows for either squares or rectangles. Those rectangles can be variable in either direction, the I or J direction. And so we are able to have a few areas that are less transitioned than others and not have to deal with exact squares or perfect rectangles. So just a quick slide showing the difference on the rectangular grid as opposed to the square grid and the results, and they're relatively the same. And you may have some extra resolution in some areas of this one on the right that shows a little bit of difference. Grid nesting, we have a parent and a child grid. So we had the larger grid here that we're forcing for with a lot coarser resolution, and then we're able to specify a spectra or take points from that larger wave grid along this edge, and then force a smaller local grid with that spectra to get results in this much smaller domain. Calculating wave run-up, we have formulations in place in using the R2% to calculate what's going on. Before this, it was all based on what the actual bathymetry showed. So if bathymetry was above 0, that cell was turned off and you never got any kind of waves on top of it. If you turn on run-up, then their potential exists for if the wave energy is there and it shows that that migration of the wave would come on shore and wet that cell, then we do allow for some inundation of some previously dry cells due to wave run-up. We can have floating breakwaters, any number of different structures. Here's just one equation that he has in here. I should have deleted the slide, but anyway, this is one formulation that we have for transmission over a floating breakwater. So we have a lot of different ones. We have bottom mount breakwater, and here's some examples. We have an island setup, and each one of these examples are going to be exactly the same setup. We just have these cells defined in such a way that they're structures and they're assigned different values. The file is written out, and depending on what values are in this file, it also changes what happens with the cells that are contained within these individual identified cells. So in this case, there's an island, there's no overtopping. It's all dry here. You have this, and you can see that the waves have to stop and then go around, and the wave energy is reduced on this side. In the next example, the same grid, these cells are changed so that they're now floating breakwater. We specify a little bit different information in the file. SMS takes care of all of that for you, and you are able to get some overtopping or wave energy. Maybe it's not overtopping, but it may actually be going underneath or what have you, depending on the setup of this particular structure cells. In this case, there's an idealized platform, and you can see some different interactions between the cells and what's going on. And then there's a submerged platform. So it's not emergent, but it is affecting the wave pickup height along this edge. And then it resolves what's going on with the wave heights beyond that. So that's just a few of the different structures that we can implement with SMS or CMS Wave. This was an animation, but it lost the animation here, just forcing some wave overtopping for a certain area with the coupled CMS and flow and wave model. And then just talking about the fast mode. Like I said, it's only used for your early part of work for a particular case. Basically what it does is it takes the standard directional bends and combines some of those direction bends so that you get 5 to 7 direction bends instead of 35. And so you wind up being either 7 or 5 times faster in your computation of the waves over that particular grid. We do have some differences in the answer, but overall the picture is relatively the same, and so you can get an idea of where the wave energy is higher or lower. But the point is, at the very end, when you're ready for your final production runs, you turn off the fast mode, and then you just wait for CMS Wave to do the regular calculations. And then we're able to combine with CMS the wave model, the wave grid, and the flow grid together to get an answer through time. And this is how we typically use for our real world cases, and very convenient. We have also used CMS Wave for breaching of some jetties in some areas. So these jetties are defined, but they're not outside of the computation. So we have allowed for them to be wet depending on situations in the flow model. And so for this case, we initially had this bathymetry, and through time, we actually got some inundation, some water coming behind the jetties on both sides. And that's about it. That's just a quick background for the waves before we start tomorrow and talking about the waves and eventually combining both waves and flow together to get answers in a run.